Let's do another computation that's going to be useful later on. And this computation, well, let's do two. So let's take sine of x, and let's linearize, that would be the verb, at x equals 0. Now, thinking back to what the sine function looks like, right? It's like the cosine, except it goes through the origin. And if you think about that, linearizing at the origin is going to produce a pretty nice line. So let's find out what this line is. It's going to end up being very easy. So if x is 0, sine of x, or sine of 0 is 0. There's our point, it's the origin. And then we need the derivative, which is cosine of x. And then we need the derivative at 0, which is cosine of 0, which is 1. And alright, so now we have our slope and we have our point, which happens to be the y-intercept. So, ergo, our tangent line is just 1 times x, or x. Or if you like, we can say our linearization is x. Alright? So, that's what we have right there. Now let's check it. Does that make sense? This is a really easy linearization, but it's used all the time. So sine of x and x, and let's make sure we're in radians. And let's go to standard zoom. Calculator suffering. What's going on here? Sine of x, x, mode, float, radian, degree. This should be fine. Well, let's change things up anyway. Let's do a min of -1, a max of 1. Let's do -1 and 1. There we go. So there's the sine function being graphed. Let's see a bit of a curve there. And look how good that tangent line is. It is right on the button. This is also called the small angle approximation of sine, because the argument of sine is an angle. So there's a range here. You can look. Where does it look good? Well, it looks dead on. At least until up around here, about 0.6 radians. We're just eyeballing this, but plus or minus 0.6 radians, and you can convert it to degrees. How many radians are in degrees? Well, there are 180 degrees per pi radians. So if you multiply that by 0.6, so 0.6 times pi divided by 180. Whoops, I did it backwards. 0.6 times 180 divided by pi gives you 34 degrees. So that's quite a spread, or it was really good. Let's do another one that's pretty common, and we'll use it in the next video. Suppose you have f of x is 1 over x minus, let's just say 1, okay, squared. And so what does that look like? Well, there's a vertical asymptote at 1, and the function's always positive, and it crosses at 1. This being able to graph things without using a calculator is a valuable skill, so you can think ahead. So alright, so here's my function. Actually, you know what? I want to make it negative because of the example I have in mind later. And so let's, I don't know, let's linearize, say 5. So let's linearize at x equals 5. So it'll be right about here, which means our tangent line is going to be something like that. So there's going to be some portion of this. Now, the further we go out, of course, the better it would be. If I did x equals 10, it'd be even better. In fact, let's go further out. little indecisive here. So if I were way out here, the tangent line is practically horizontal. Let's see how that works out. So if we're doing it x equals 10, then f of 10 is minus 1, 10 minus 1 squared, minus 1 over 9 squared is 81. So it's not a very big y value. And we need the derivative. Let's think of this as minus x minus 1 to the minus 2. So we can use the power, it'll be a chain rule, but power rule first. That'll give you a minus times the minus 2 that we brought down, times x minus 1 to the minus 3, times the derivative of the inside. So this is 2. Let's put it back in the denominator now. I like moving in and out of the denominator as it makes things easier or harder. Now, if I want to evaluate the derivative at 10, that's going to be 2 over 9 cubed. I think it's 9 cubed. That's 2 over 729. That's small. So our line isn't going to be very steep, not surprisingly. So what do we have? Well, just to make things a little simpler, we'll use the formula this time. So the linearization is going to be 2 over 729 x minus 10 plus the y value, which is a negative 1 over 81. So this is 2 over 729 times x minus 20 over 729 minus 1 over 81. This is the same thing as 9 over 729. So this is minus 29 over 729. All right, so there's our tangent line. Let's see if we can make this work. So our function is minus x minus 1 raised to the power of minus 2. Let's use some parentheses here just in case. And then our tangent line, whoops, is 2 divided by 729 x minus 29 divided by 729. And again, let's use some parentheses. And let's see, for the window, minus 1's fine. We need a bigger max, maybe a 212. We don't really need a y max of anything bigger than 0. So here's the curve, which is our function, and it's pretty small. There's the tangent line. All these things that I'm doing are also really important skills. Let's make this point 1. Play with your window. Don't just take what your calculator gives you, but manipulate your calculator. The calculator is the tool that you use. Well, there we go. There's that nice tangent line. And let's extend our x's off a bit further. And we can even go maybe 0.5 here. And get a really nice picture of what's going on. The process here, there's that tangent line, is again, you're taking derivatives, you're using points. So if we're using trace, if x is 10, there's y. So hope that's been helpful.